Good morning, and welcome to our channel. Happy New Year to all of you. Don't worry, this channel is not going to be nothing but 3i Atlas all year long. If for no other reason, the object is eventually going to leave the solar system. But right now, there is new information about this thing that simply cannot wait. I actually sat on this update for about 48 hours, and I want to explain why. Yesterday, I made a public apology to a very special person, someone who truly is a space pioneer in her own way. It was something I felt needed to be said, and I didn't want anything to overshadow it. If you haven't seen that video, please do. I think it's important that when I make a mistake, especially one that could be harmful or unfair to someone else, I don't bury it or quietly move on. I don't want to hide behind the fact that only a fraction of subscribers saw it. I want everyone to see it. I'll link it at the end of this video. Now, with that said, let's talk about what's happening with 3i Atlas, because things just took a very sharp turn. This object has been strange from the beginning, but the single most persistent and troubling anomaly remains the same: the anti-tail. The sunward-pointing structure that should not exist at this scale, at this distance, for this long. And now, it's not only more prominent than the conventional tail, it appears to be part of a three-jet system, not just one or two. Even more intriguing, those three jets exhibit a symmetry that is very difficult to ignore. This is something many observers have commented on for weeks, but Avi Loeb himself had not directly addressed it until now. And I'll be honest, that hesitation mirrored my own. Between AI-generated imagery floating around online and over-processed amateur images, I was not comfortable assigning meaning to symmetry unless it could be demonstrated cleanly, consistently, and with real data. Now we have that data, but that isn't even the main story. The main story is this. Avi Loeb has now stated, based on raw physical constraints, that 3i Atlas cannot be a comet. Not probably not. Not unlikely, cannot. And that is a very big claim. So let's walk through exactly how we get there, slowly and carefully. What you're seeing throughout this video are images taken by the Hubble Space Telescope and processed using the Larson CCIA rotation gradient filter. This filter does not invent structures. What it does is remove smooth, symmetric coma light and amplify gradients, making directional features easier to identify. When we zoom out to scales of roughly 100,000 kilometers, the picture is already unsettling. The anti-tail dominates everything else. It is far brighter, far longer, and far more coherent than the conventional tail. But if you zoom in closer, down to scales of about 24,000 kilometers, something else becomes obvious. Three distinct jets appear, separated by roughly 120 degrees from one another. One jet points roughly sunward, one points roughly anti-sunward, and the third points sideways, completing a near-perfect triad. This structure was observed on November 30th and again on December 27th. These are new features that appeared after perihelion and after the closest approach to Earth. In other words, this object is still evolving rapidly. On large scales, the anti-tail dominates. On smaller scales, the three-jet structure becomes obvious. The equal angular separation is what raises eyebrows. Three jets spaced evenly around a full 360-degree circle is not something we see often in natural cometary activity. The orientations of these jets change over time, consistent with rotation of the nucleus. The standard comet interpretation would associate jets with discrete volatile reservoirs on the surface of a rotating icy body. Heat from the sun triggers sublimation in these pockets, producing jets. That explanation can plausibly account for jets extending a few thousand kilometers. If gas is leaving the surface at around 200 meters per second, then over several hours you can indeed build structures several thousand kilometers long. But here's the problem. The anti-tail is not a few thousand kilometers long. It is hundreds of thousands of kilometers long, and that changes everything. The rotation period of 3I Atlas appears to be about 16 hours. Variations of a few thousand kilometers in the minor jets over half a rotation are physically plausible. But maintaining a coherent, tightly collimated sunward jet over distances exceeding 100,000 kilometers, let alone several hundred thousand, requires long-term stability. That stability is only possible if the jet is aligned extremely closely with the rotation axis. The anti-tail is more than 10 times longer than it is wide. That implies a misalignment of less than 6 degrees. In other words, the jet must be located very near one of the rotational poles. On top of that, the rotation axis itself must be aligned very closely with the direction of the sun. The probability of such an alignment occurring randomly is on the order of 2%. Once again, we're stacking improbabilities. Symmetric jet spacing, polar alignment, sunward stability. Each one individually might be tolerable. Together, they strain credibility. But now, we arrive at the critical test. The test that does not depend on interpretation, aesthetics, or pattern recognition. The test that depends only on physics. What is physically possible for sublimation? A comet, by definition, is an icy nucleus that outgasses when heated by the sun. That outgassing creates gas flow and entrained dust. The gas leaves the surface at roughly the thermal speed of the dominant volatile. In the case of carbon dioxide, that speed is about 200 meters per second. That is the absolute ceiling. Now compare that to the solar wind. The solar wind travels at roughly 500 kilometers per second. That is 2,000 times faster than sublimated gas. This matters because gas does not coast indefinitely. It is stopped when the outward pressure of the jet balances the incoming pressure of the solar wind. Avi Loeb ran the numbers. He calculated the gas density as a function of distance from the nucleus, using mass loss rates measured by the James Webb Space Telescope. Before perihelion, the mass loss rate was around 150 kilograms per second. Near perihelion, it likely increased to around 500 kilograms per second. That's a lot of material. But even at that rate, the math is merciless. The maximum distance that CO2 gas ejected by natural sublimations can travel sunward before being stopped by the solar wind is about 5,000 kilometers. That's it, 5,000 kilometers. And that number is not arbitrary. It coincides almost exactly with the observed radius of the inner coma around the nucleus. Beyond that distance, there should be no streaming gas at all if this is a natural comet. Dust, yes. Gas, no. This gives us a clean, unambiguous test. If 3I Atlas is a comet, then the anti-tail beyond 5,000 kilometers must be dust only, with no detectable gas. But here's the problem. We already checked. The James Webb Space Telescope has already performed spectroscopic analysis of the anti-tail well beyond that distance, and carbon dioxide is detected far outside the coma, tens of thousands of kilometers, possibly hundreds of thousands. That should not be possible. Natural sublimation cannot sustain streaming CO2 gas at those distances. The physics simply does not allow it. At this point, something has to give. Either the laws of gas dynamics are wrong, or this object is not behaving like a comet. Avi Loeb argues that the conclusion is unavoidable. If the anti-tail contains streaming gas beyond 5,000 kilometers, then 3I Atlas is not a comet. So what could it be? Loeb outlines a comparison. Chemical rocket exhaust with velocities of 5 kilometers per second could push gas out to 25,000 kilometers. Ion thrusters with exhaust velocities of tens of kilometers per second could extend gas streams to 100,000 kilometers or more. That immediately opens uncomfortable doors. Ion engines are not science fiction. We build them. We fly them. And yes, carbon-based propellants, including CO2 mixtures, have been studied for Hall and ion thrusters. There is another possibility as well. If the anti-tail is not propulsion, it could be protection. A plasma-based shield composed of charged ions would interact strongly with the solar wind, deflecting incoming particles and reducing radiation damage. Plasma shields are actively researched. Magnetohydrodynamic confinement of ionized gas is real physics, not speculation. Such a shield would naturally form a long, sunward-oriented structure composed of ions. And such a structure would look very much like what we are observing. One more speculative idea pushes this even further. If the particles in the anti-tail are not dust at all, but active agents interacting with the solar wind, harvesting or redirecting energy, the scale of the structure becomes even more significant. The solar wind carries immense energy. A 1,000,000-kilometer interaction region would intercept a staggering amount of it. Do we have evidence for that? No. Do we have the data yet to rule it out? Also no. What we can say, with confidence, is this. Natural sublimation cannot explain streaming gas in the anti-tail beyond 5,000 kilometers. James Webb has already detected CO2 far beyond that limit. Therefore, 3I Atlas does not meet the physical definition of a comet. Whatever this object is, it is something else. And now, the burden shifts to the broader scientific community to grapple with that conclusion. Thank you very much for watching. Please like, subscribe, and if you are able and comfortable doing so, consider supporting the channel. January is brutal for creators, and viewer support is what allows me to keep covering topics that aren't algorithm-friendly but still matter.